So hello everyone, welcome to OneClass. My name is Shanjida. I am currently a second year human biology student at U of T, and today I'll be going over some commonly asked chemistry questions both at the high school slash university and college levels. And if anyone needs any additional help with schoolwork or needs tutoring, you can check the description box below. And other than that, let's get started. Okay, so over here, our first question says, what is the molar mass of copper II sulfate? Okay, and so copper II sulfate. So let's first write out the chemical formula for copper II sulfate, and since it mentioned here that it's copper II, so copper II means it has a charge of 2+, and sulfate, this is sulfate, and it also, well, it has the opposite charge, which is 2 negative, negative 2. And so to get the formula, you just need to crisscross, right? And you get copper, and you just get SO4. Okay? And so this is your chemical formula for copper II sulfate. And so here we are trying to find out the so here we're trying to find out the molar mass. And so molar mass is basically the same thing, well, basically the same number as your atomic mass. It's the atomic mass number. Okay, and what I mean by this is, let's for example, let's take copper in our first case, and so let's find the molar mass of copper first. Molar mass, I'm just denoting mm as molar mass, and so we have copper here, and so the molar mass of copper, you can say that this is the same thing as its atomic mass. And you know how you find atomic mass? It's the number of protons and the number of neutrons in the nucleus of that element. And so the molar mass of one copper atom is basically 63.546 grams per mole. Okay, so this is the same thing as one atom of copper is equal to basically 63.546 atomic AMU, basically the unit for atomic mass. And so basically you can get this from your periodic table. It's actually given in your periodic table, and so you don't really have to do that much calculation here. And so the next thing we would want to do is find the molar mass of sulfate, right? But so since sulfate is SO4, it actually has 2 elements, and so we're going to break that down into 2 separate molar masses. So we would first find the molar mass of sulfur. Okay, so in sulfate there's only one atom of sulfur, and so the molar mass of one sulfur atom is 32.065 grams per mole. Okay, again, you can get this from your periodic table, and it's actually equal to the same thing as your atomic mass of sulfur. And so the second last step would be to find the molar mass of O4, right? Because it's sulfate. Sulfate is SO4. And so we would find O4. So the atomic mass of one oxygen atom is 16.0 grams per mole. And since we have 4 in this case, you have to multiply this by 4, and you basically get 64.0 grams per mole. Right? And so the last step right now would be to add all these numbers together. So molar mass of copper sulfate, it would equal to, so we have here 63 63.546 grams per mole, and then you have 32.065 grams per mole, and then you have 16.000 grams per mole. Okay, and so you just have to add all this together. Oh, you have 64, sorry, this is 64. And so what you get here is plus 32.065. So I get around, you get here 159.611 grams per mole. Okay, and so we can say therefore, the molar mass of copper II sulfate, also as CuSO4, is 159.611 grams per mole. Okay, and so yeah, this is what I have got, and this is correct. So our next question here says, what is the molar mass of iron? Okay, so let's, so they're talking about iron 2, I believe, because that's the natural, that's the basically, or yeah, they're talking about iron. So basically, so iron, right, the symbol for iron is Fe, and so we're trying to, so to find the molar mass of iron, is basically, you can get this from your atomic mass as well. And so the atomic mass of iron, let's just say atomic mass, or let's write it in terms of molar mass here. So we can say molar mass of iron, which is Fe, is the same as the atomic mass, right? And so we can say that basically your atomic mass unit, it's actually called atomic mass unit, is basically equal to the number of protons, which are plus, and plus your neutrons, number of neutrons. And so, okay, so your atomic mass of iron is basically, so it is basically, it's given in your periodic table, and this is 55.845 AMU, so atomic mass unit. And so you can say that therefore molar mass of one Fe atom is 55.845 grams per mole. So just keep in mind the units here. When we're talking about atomic mass, we're actually talking about atomic mass unit, and when we're talking about molar mass, it's grams per mole. Okay? And yeah, you get this from your periodic table, and this is correct. So our next question says, what is the molar mass of phosphorus? So phosphorus right, this is P, and phosphorus is a non-metal, right? So it's gonna be, so phosphorus, this is a non-metal, so it's part phosphorus group, so it's in the group 5, right? It's in group 5. It has 5 valence electrons. Okay, and so basically, so this is just a background, basically what phosphorus is and which group it is in. So however, to find the molar mass, and we can say this is the same thing as the atomic mass, where the units are different, right? So your units for atomic mass is AMU or U in some cases, and molar mass is grams per mole. Atomic mass is equal to AMU slash U or U. So you can get this from your periodic table, right? Or you can calculate the atomic mass, which is actually the same thing. So you just do number of protons and number of neutrons. And so we can say that this is basically number of protons plus number of neutrons. And so basically you have 15 protons in phosphorus and approximately 15 neutrons, and you get an atomic mass of 30 AMU. And so we can therefore say that molar mass of phosphorus P is approximately 30 grams per mole. This is 1 atom of phosphorus, okay? And so it's approximately, you can say, but the actual molar mass is given in your periodic table, but this is the way you can actually find the molar mass. So this is correct. And it depends on if you round your number or not. I would suggest not rounding your number and just to keep it exact. Okay. Next question. Number 4. It says, okay, which of these statements, so it says, which of these statements are true for a neutral aqueous solution at 25 degrees Celsius? Okay, so in order to find the what the correct statements are, we need to first address what is a neutral aqueous solution is, right? And so a neutral aqueous solution is basically, this is basically when your pH, so pH is equal to 7, okay? This is when your pH is equal to 7. So in this case, this is basically like water, okay? So like, as an example. And so if you have your pH is equal to 7, that means so when we're calculating pH, we're talking about our protons are basically our H plus ions and our OH hydroxide ions, right? And so when your pH is 7, so that's neutral, that means your number or the concentration, so the concentration of your OH negative ions and H plus ions are equal. Okay, so this is what, so what we mean by this. When your OH and your H plus ions are equal, so the concentration is equal, that means it's not, so what this means is it's not acidic, right? It's not an acidic solution, nor is it a basic solution, right? So it basically, you can say it cancels each other out and you have a neutral solution. Okay, so in this case, the answer would be statement 2 and statement 4. Okay, yes, and so this is where your kW is actually equal to your kW is equal to basically 1.00 times 10 to the power negative 14, right? So that means those two are equal, and so the answer is so it says D and equation 1, so yeah. Okay, so basically it's 2 and 4. Okay, pH of the solution, so the correct answer is 2 and 4, right? your pH is equal to 7 and the concentration of the ions are equal to the concentration of OH, right? It can't be number 3, so the concentrations of H plus ions is less than the concentration of OH ions, so that means we have more hydroxide ions, and that means your solution is going to be more basic, so you would have a pH of higher than 7, and it can't be number 1 because the pH of the solution is less than or equal to 7. It's partially right. If it's less than, that means your pH is below 7, and that means your solution is mostly like near acidic, so that cannot be right. And so your answer in this case is basically D. So the answer is right? Okay, so number 5. Next question says, how is conjugate acid and bases identified? Okay, so and so what you do here is basically a conjugate acid, right, is that has one or more H protons, H plus ions basically. So a conjugate acid has one or more H plus ions than the base that formed it, right? So your bases, as you recall, your bases don't have they don't have like a plus and a proton, right? Because your bases are formed by OH ions, and so then the base that it is formed by. Okay, and so where on the other hand the base contains your conjugate base, so in comparison, you can say in comparison, the conjugate base contains one or one less H plus ions or atoms, and one more, so basically it has more negative charge than the acid it was formed by. Okay, and so basically, for instance, like for example, let's say right, we have bicarbonate ions, so HCO2 negative, these are ions, it reacts with water. Okay, and so it forms it produces carbonic acid and hydronium, and it produces basically hydroxide ions, and so you have H2CO3 plus OH negative, right? And so the pattern here is, you can see that since this is negative, right, this would be our base, and water in this case acts like our acid. And so what you get here your acid, right, because this contains one more H atom than your base, And so, I don't know why this is okay. And so this is a negative, and so this is your conjugate. This is your conjugate, right? And so this is your base. Okay, so this is your conjugates. So this is your carbonic acid is your conjugate acid, and your hydroxide ions are your conjugate base. And so you can basically see that your bicarbonate becomes your carbonic acid by having one more H atom. And so you can say that, therefore you can say that H2CO3 is the conjugate acid of HCO2. Oh, sorry, this is CO3. My bad. CO3 negative. This is CO3. Okay. And so you can also say that the water, H2O in this case, you can also say H2O becomes OH, right? So you can say that your OH formed from your that comes from the water molecule here is the conjugate base of H2O. Okay, and so this was how you identify conjugate acid and bases. Okay, and so this is correct. Next question says, select the correct IUPAC name for the following branched chain alkane. Okay, so first, we have our chain over here, and so you can basically, so to do this, you first have to identify the parent chain in this case. And so the parent chain consists of the longest continuous carbon chain. And so if I were to, let's say, write this out, have CH3 CH2 CH, and I have CH2 CH3. Okay, and you have here CH2 CH3, and you have here a methyl CH3, and then lastly you have one chain going here, so CH2 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 CH3. Okay, so now we have to identify basically our longest chain in this case. And so let's start by counting from here, let's say. Okay, so our longest parent chain in this case, we would have to count which chain has the most carbons. And so we can probably guess that, let's say 1, 2, 3, 4, 5, 6, 7, 8, right? So going across like this, we have 8. How about let's just check this zigzag kind of diagonal thing. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Or sorry, so let's just say until here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you're just gonna say these 3 groups of carbon here. Okay, and so our parent chain in this case would consist of basically this group here. Okay, so it would be this group here. And so since it has 9 carbons, just gonna write 9 carbons. 9 carbons. And so this becomes, so your parent chain has 9 carbons, so it's called a nonane, right? And so now we basically have to identify the groups attached to the parent chain, right? So we have to identify, so we basically have to identify this group right here, this group right here, and this group right here. Okay, and so what we're gonna do here, is find the substituents, and we have to number them, number the parent chain from the end such as that the substituents get the lowest numbers, right? And so we can basically say here, this right here, since it has 1, 2, 3, 4 carbons, this is a butyl, right? And this has 1 carbon, this is a methyl. And this right here is your ethyl, right? You have 2 carbons here, this is your ethyl. And so what we're gonna do here, we're just gonna write our substituents down and say, so substituents, okay? And so we have butyl, we have our methyl, and we have our ethyl. Okay, so now we have to basically find what carbons it is attached to. And let's say if we count our carbons here, if we count our carbons from, let's say, here, right? Because the chain has to end from that the substituents get the lowest numbers. So let's say we start our chain from here. So like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so you can see on our second carbon we have our butyl, right? So it's gonna be 2 butyl, and then we have our methyl on the third carbon right here, and so we can say this is 3 methyl. And then lastly we have our ethyl right here, and this is attached to 4, 5, 6. Our 6th carbon is attached to our ethyl, and so we say this is 6 ethyl. Okay, and so finally now we have to write the numbers and the names of the corresponding substituents in alphabetical order before the name of the parent chain. So we have to write this substituents in alphabetical order before basically naming the parent chain, which is nonane. And so the alkyne name is, so if we write this going alphabetically, so we have here, so B comes before M and E, so we have here, first of all, let's do this. So we have 2-butyl, then comes E, right? Because E is before M, and so we have 6-ethyl, and we have, then lastly we have 3-methyl. 3-methyl, right? You don't need a hyphen after this methyl, and it's just nonane. Okay, and so our alkane name is 2-butyl 6-ethyl 3-methyl nonane. Okay, and so this is what they have got. The solution is correct. Okay. So our next question here says, explain why the molecule fluoromethane CH3F is polar. So fluoromethane. Okay, and so this is the way you write it, is CH3F. Okay, and so you can see here that, so to draw this, we basically have 3 atoms here, or 3 elements, and so this is gonna be a tetrahedral geometry. And so what we have here, C is our central atom, F, we have H, actually let me write this like this, H, and then you have a wedge right here, this is your H, and this is going behind, right? So it's back of the plane. This is your other hydrogen. Okay, so this might lead you to think that it's non-polar, but it's not, because so they have different magnitudes and polarities, and what this means is your CF bond right here, so let me denote this, so this bond right here, this is slightly more polar than your CH bonds right here. Okay, so it's more polar, and so what that means is, because your fluorine is more, so let's make it like this, so CF bond is more, basically more polar than your CH bond, and this is because fluorine has a high electronegativity. Okay, and so this makes the molecule polar, even though, so this is why this this is why this molecule is more polar than, this is why this molecule is polar, even though it has a tetrahedral geometry. Okay, and so the solution is correct. Okay, so our next question here says, over here says, is basically calcium carbonate solid or aqueous. And so calcium carbonate this is how you write it, CaCO3, right? So it's determined if it's a solid or aqueous by determining its solubility, and so group 2 elements are combined with the carbonate are generally insoluble. And so basically if you were to mix calcium and group mix it with carbonate, and it would actually be insoluble. And so it's basically an aqueous solution. Okay, and so is aqueous. Okay, and so this is carbonate. And so that was the end of our session. If you really like this Q&A, subscribe to this channel, and if you have any personal questions, you can follow the links down below. And other than that, I am Shanjida, and I'll hope to see you soon.